Hi, today we're going to discuss 3 problems from University Physics, Chapter 14. Let's get started. 14.9. An object is undergoing simple harmonic motion with period 0.9 seconds and amplitude 0.32 meters. At t equals 0, the object is at x equals 0.320 meters and is instantaneously at rest. Calculate the time it takes the object to go from x equals 0.32 meters to x equals 0.16 meters, and b from 0.16 meters to x equals 0. So for this problem, we're mainly going to use this equation, x equals amplitude cosine quantity omega t plus theta. So we have the position already given by the problem. We just need the omega and the theta. So first, to find theta, we'll simply substitute x equals 32.32, and since we know it's instantaneously at rest, omega will be equal to 0 at that time. So we'll be left with 0.32 equals 0.32 cosine 0 plus theta. So 1 equals cosine theta, and therefore theta will be equal to 0. So next, to find omega, we'll be using this formula, 2 pi f, or since we're given period, so it's 2 pi over t, since we know f is 1 over t. And so we'll substitute the values, and we'll get omega equals 20 pi over 9 rads per second. So now that we have all the missing data, we can now find the times. So for letter A, time at 0.16 meters. So we'll just simply substitute 0.16 and the omega and theta we found to get 0.16 equals 0.32 cosine 20 pi t over 9. And we can just transpose 0.32 over and get the arc cosine and divide by 20 pi over 9 to get time, which is 0.15 seconds. Now moving on to letter B, from time x equals 0.16 meters. Since we have the time for that, we just need at the time at x equals 0. So substitute the values again to find time, and we find it to be 0.225 seconds. And we'll just minus it with the first time to get the duration between the two, to get an answer of t equals 0.075 seconds. And that's 14.9. Let's move on. 14.25. A tuning fork labeled 392 Hz has the tip of each of its 2 prongs vibrating with an amplitude of 0.6 millimeters. What is the maximum speed of the tip of the prong? Letter A. Letter B. A housefly Musca domestica with mass 0.027 grams is holding onto the tip of one of the prongs. As the prong vibrates, what is the maximum kinetic energy? Assume that the fly's mass has a negligible effect on the frequency of oscillation. So for this problem, we'll find omega again to start off, and simply substitute f, which is 392 Hz, and we'll get an omega of 784 pi rads per second. Now, to answer letter A, we'll let theta equals 0 to simplify the problem. And we'll use this formula, v equals negative omega a sine omega t plus theta. And we can just substitute values, and the reason why there's 1/4 is because we know that the maximum velocity always occurs at 1/4 of the period. So that explains the 1/4, and the period is simply 1 over f. And so yeah, just substitute the omega. And remember that 0.6 is in millimeters, so that's why it's times 10 to the negative 3. And we'll get a Vmax, which is equal to 1.48 meters per second. So yep, there it is. And now we can answer letter B. Yeah, mass is 0.027 grams, or 2.7 times 10 to the negative 5 kilograms. And so to get the kinetic energy, maximum kinetic energy, that's just simply equal to the total energy. And first you'll need to find K with this formula. Substitute the values. Since the maximum velocity also occurs when x equals 0, that's why x equals 0. And you can simply transpose. To find K, divide both sides by square root of 0.6 squared. And sorry, that's supposed to be 0.6 times 10 to the negative 3 squared. And you'll get a K equals 164.28. And you can substitute it to the formula of E, which is 1/2 Ka squared. Again, 0.6 times 10 to the negative 3, and you'll get an E of 2.96 times 10 to the negative 5 joules. Now for this problem, you can also use the formula to get kinetic energy, since it's the maximum, and we know the maximum velocity, so that'll just give you the same answer if you substitute the values, 2.96 times 10 to the negative 5 joules. And lastly, 14.45, you pull a simple pendulum 0.24 meters long to the side through an angle of 3.5 degrees and release it. How much time does it take the pendulum to reach its highest speed? B. How much time does it take if the pendulum is released at an angle of 1.75 degrees instead of 3.5 degrees? So this is the diagram. And for a simple pendulum, there's two formulas that you need to remember, but for this problem, you just need to know that T equals 2 pi square root of L over G, since we're given the period. And you can just substitute the values to find period. So that's 2 pi square root of 0.24 over 9.8 square meters per second squared, and you get a period of 0.9833 seconds. So that's just the period, but we need the time it takes to get the highest speed. And we know from a while ago, Vmax is always at 1 for T. So T equals, to get the time, that'll be just the period divided by 4. And we'll get an answer of 0.25 seconds. To answer letter B, it's how much time does it take if it's released at a smaller angle. The answer is simply the same, 0.25 seconds. Because it's a simple pendulum, only the length of the pendulum matters with a small theta. Thank you for watching. I hope you learned something. And sorry for the typographical errors.